So we're putting together the pieces for yesterday. On question 1, write down write each of the following as a trig. A trigonometry ratio of positive acute angle. So write each of the following as a trigonometric ratio of positive acute angle. There, sine negative 194. So yesterday we talked about the quadrants. So we said we have 4 of them. And then the angles are moving from 0 to 90 to 180 to 270 and to 360. They are moving in this way, positive and increasing, positive and increasing. Now these angles can also move in reverse. They can also move in this direction. So if they do so, they will start from 0 and go to negative 90 and go to negative 180 and go to negative 270 and go to negative 360. If they go in reverse, meaning that between 0 and 90, it is still in the 4th quadrant. Same behavior of the trig signs between 0 and negative 90. Between negative 90 and negative 180, it is still the 3rd quadrant. Same behavior, same sign. Here, it is still the same. Here, it's still the same. Same signs, same behavior of any angle, regardless of the angles being negative or positive. So we are talking of negative 194. So we know in the negative sense, this angle is in this region here. Okay. Now it being in this region, what else do we know about sine? We know that sine is an odd So we're saying that the angles move from 0 to 360 in this direction. In this anti-clockwise direction. If they move in the clockwise direction, then they become negatives. And they maintain the behavior in each quadrant. So now we are talking of this angle here. We say that sine is an odd function. So sine negative 194 is the same thing as sine as negative sine 194. Since it's an odd function, so the negative can come out. If the negative come out, then we are now dealing with 144 that lies in the 3rd quadrant. And now we can get its reference angle by subtracting 194 minus 180 because it's in the third quadrant. So here we'll get 20, no, we'll get 14. Meaning that this will be the same thing as negative sine. But because we are talking of 14, that lies in the first quadrant where sine is positive. Then for us to go to 14, we'll say negative sine 14. Meaning we have gone to use an angle from the first quadrant, when we are having an angle from the third quadrant. So to take care of that shift, you put a negative there. So that negative times negative, we get positive sine 14. This is one way. Or you get the coterminal angle. You get the coterminal angle of negative 194. Because negative 194 is less than 0. For us to bounce back to the required angles, we'll add 360. So 194 plus 360. So this will give us this will give us 360 minus 194. It will give us 166. So 166. So now the coterminal angle. Remember we said coterminal angles are the angles sharing the same starting point and the same ending point. So this negative 160 or 194 is an angle that goes this way, up well, up to in this region. So this is negative 194. We also have an angle that is in this direction, which is positive 166. So these two angles are coterminal to each other. So when we use a coterminal angle, there is no need of signs because they do not change signs. They give you the exact value. So we are saying this sine negative 194 is equal to sine 166. Now 166 is not an acute angle. So because it's not an acute angle, then we'll say, okay, let's get its reference angle. The reference angle of 166 comes from the second quadrant. 166 is in the second quadrant. Because in the second quadrant, to get x, we'll do 180 minus 166. So we get 14. So this is exactly sine 14 degrees. Exactly because 14 is in the first quadrant where it is positive, but sine is positive in the second quadrant as well. So that's how we get this solution here. B cos 481 degrees. So there, you now will go straight to the coterminal angle. What are coterminal angles? What are coterminal angles? Coterminal angles are the angles. Coterminal angles are the angles that share the same starting point and the same end point. That's how they are defined. We say two angles are coterminal because they share the terminal points. They share the starting point and the ending point. So if I have an angle that is starting from here and it ends there, this angle is coterminal to the angle that starts from here, goes round and ends there. This angle is coterminal to an angle that starts from here, goes this way. That starts from here and goes this way. It's coterminal to an angle. Coterminal to an angle that starts from here, goes round, and goes all the way up to here. As long as they share the same starting point and the same ending point, no matter how big they are, we call them coterminal angles. They share the terminal points. So that we don't forget, we say not. I don't get what do you mean by question one was solved. We are on question one. Okay, so coterminal angles are angles that share the starting point and the end point. Okay, that's okay. So now we use coterminal angles in this case. So we're saying we'll get since 481 is bigger than 360. So what we'll do is we'll subtract 481 minus 360. What do we get? We get 121. So we get 121. So what we are saying now is that cos 481 is exactly equal to cos 121. But where do you find 121? 121 is found in the second quadrant. It's bigger than 90, but less than 180. So because it's found in the second quadrant, then we need to use the reference angle. Remember, the reference angle are the angles between 0 and 90. Reference angles are the acute angles. So we need an acute angle. So now we get 180 minus 121. That is 59. So we have cos 59. But when you get reference angles, you must be careful of the quadrant. This 59 comes from the first quadrant, and yet it's a reference angle of an angle in the second quadrant, where cos is negative. So you indicate that this is going to be now negative cos 59. Okay, negative because cos is negative in the second quadrant. Okay, we go to C, we find tan 185 degrees. Again, because 185 is not an acute angle, then we'll get the reference angle, that is an acute angle, by doing 185 because it's bigger than 180 and less than 270. So we'll say 185 minus 180, we get 5. So we'll say this is equal to tan 5 degrees. Tan 5 is in the first quadrant. 185 is in the third quadrant where tan is positive as well. So we'll leave it just like that. G sine 331 degrees. 331 is not an acute angle, though it's less than 360. So what we'll do is we'll subtract, because it's bigger than 270, we'll subtract it from 360. So we'll get 29. So what we are saying is that this guy is going to be equal to sine 29 degrees. But 29 is in the first quadrant, whereas 331 is in the third quadrant. In the third quadrant, sine is negative. So we indicate a negative here, showing that the angle whose reference is 29 is in the third quadrant. So because now we are outside the exam, we can be checking these things. You check what is sine 331, you get negative 0.48. 480,962. Negative 0.48. We get those key first two numbers. What is sine 29? You find it's positive 0.48. It's the reason why we have to put a negative so that we have the same values. So when you check, you find sine 331 is equal to 0.48 if we round off, and yet sine 29, I mean, this is negative, and yet sine 29 is positive 0.48 if we round off. This is because of the quadrants where these two belong. Now, to show that the 29 has come in because of 331, you put a negative here so that you have the same value. 29 is in the first quadrant. 29 is in the first quadrant, but it is a reference angle. Reference angles go around quadrants. So we have 331 in the fourth quadrant. We have an angle here, 331. So we can get its remaining piece for it to form 360, which is a reference angle. So when we get a reference angle to be 360 minus 331, we'll get 29. But 29 does not belong to this quadrant. It belongs in the first quadrant, where sine is positive. And yet you're looking for the value of sine 331. Though we can use 29 to get sine 331, there is a way we must use it. That way is to use it as negative sine 29. So we will borrow the sign from the quadrant where 331 belongs. That's how you know the sign. So what are we taking here from question 1? We are saying if you use coterminal angles, the signs of the trigonometry ratio does not change, because coterminal angles give the exact same value. The angle, why did we use 180 and not 70? We said that the reference angle will always start from the x-axis. If it's not starting from the x-axis, then it will end at the x-axis. It will always have this behavior, like this. These are reference angles. Sitting in this way, sitting in this way, sitting in this way, sitting in this way. They will always lean on the x-axis. That makes it a bit awkward for this code, because if you use 270, then it will lean on the y-axis. But you don't want it to lean on the y-axis. It must lean on the x. So the only way to lean on the x is when you subtract from that angle from 180. I mean 180 from that angle. 2, if you use reference angles, make sure that you check the sign of, if you use reference angles, make sure that you check the sign of the trigonometry ratio. You check the sign of the trigonometry ratio in the quadrant where the original angle is. Part 3, to obtain a reference angle, consider the following. A, all angles from the first quadrant are reference angles of themselves. B to obtain a reference angle of an angle between 90 and 180. Subtract the given angle from 180. C to obtain a reference angle of an angle between 180 and 270. Subtract 180 from the given angle. And D to obtain a reference angle of an angle between 270 and 360. Subtract the given angle from 360. All reference angles lie in the interval 0 less than theta less than 90. These are what we call reference angles. They are also called acute angles. So always take note that when you want to answer question 1, these are things that you must keep in mind. That if I want to use the coterminal angle, then the sign won't matter. If I'm using a reference angle, then the sign of the trig that I'm dealing with in the quadrant where I find the actual angle given in the question matters. Because reference angles will always come from the first quadrant, where all trig are positives. Okay, so we'll be logged out. Because I'll have another class for engineering students, so I don't think we'll have time to log back. Unfortunately, our time got screwed up by the error, by the fault of the Zoom. So today I won't give you the task because I think yesterday I didn't give you a task. Okay, so today I'll give you a task. Today I'll give you a task to answer and submit question 2. Question 2B and I. Yes, we recorded yesterday and posted on our YouTube channel.
So where are we supposed to submit?
You submit the WhatsApp. That's given 2. B and
okay.
I. So B and I are not being complicated. At least I expect you to submit before tomorrow. 0 to 30. So you can submit. Like I'll post.
So you mean like 02 in the morning or like 14 hours?
02 in the morning. AM. Not 14 hours.
Sir, kindly send the video after class.
Okay, I'll send.